Hi everyone, and welcome to Math 141. In this video, we're going to complete an investigation. And this investigation will introduce you to several aspects of the course. The notion of definitions, and the sorts of investigations that we're going to be completing in the course. This investigation focuses on points and rays. Before starting the investigation, we first need to define or talk about what a ray is. Okay, so a ray is a portion of a line starting from a given point, which we're going to call the endpoint, and extending in one direction without ending. To create a ray, what you need you need several things. First of all, you need an endpoint, and that endpoint we'll call E. And you need a point, basically you need the line. In this case, we've got line AEC. And then you need another point, so just to give you a sense of the direction that the ray is extending. So if we start at endpoint E and extend in the direction of point C, we have ray EC. Notice what I do is I start, so the first point is the endpoint, and the other point indicates the direction that my ray is extending. I could also have started at point E and extended in the direction of point A. So that would be ray EA. Again, you start with the endpoint and indicate the direction that the ray is extending. So that's a ray. When you create definitions in this course, there's two things I'm going to ask you to do. One, give a sentence, write a sentence that explains what the thing is, in this case the ray. And two, give me an image, a drawing of what this thing looks like. In technical terms, this is called the concept definition. The image is called the concept image. And now for the investigation. Suppose there are 2 points on a plane. How many distinct or different rays can be created by these 2 points? Okay, so if you have 2 points on a plane, you can create 2 rays. You can create a ray starting at A and extending through B, so that is ray AB. Or you can create a ray starting at B and extending in the direction of A, so that would be ray BA. Notice you can't just say ray A, because ray A might go in this direction or that direction. It doesn't use both of these points. The question is, how many distinct or different rays can be created by these 2 points? So with 2 points, you've got 2 rays. Now, this extend the problem upward. What if we have 3 points, and these 3 points are all collinear? We'll call them A, B, and C. How many distinct rays can be formed by these 3 points? Okay, let's use different colors to denote the different directions. We can start at ray A, or excuse me, point A, and extend through point B or point C. That would give you basically one ray. We'll call that one ray AB. Notice that ray AB and ray AC are the same, so that's the same as ray AC. So even though they have different names, they would not be distinct or different. They would have the same points, in other words. You could also talk about ray BC. Notice again, you can't talk about just ray C, because ray C could go in any of these other directions. It doesn't use the other points to define it. So you've got 2 rays moving in sort of towards the right, and then we'll get a different color. The rays coming towards the left, you'd start at point C and go through points B and or A. So that would be ray CB, for example. Or you could start at point B and move through point A, and that would be ray, that would be ray BA. So if you have 3 points, there are 1, 2, 3, 4 distinct or different rays that could be created. if you have 4 points. Let's see if I can draw all of these. You've got 1, 2, 3, moving in the other direction. 4, 5, 6 distinct rays. Again, all of these 6 rays are distinct. They use the points on basically the collinear points, and they're distinct, meaning none of them share exactly the same points. Lastly, what we want to do, and this is what we also often want to do in elementary school, is you want to try to extend the problem. Let's look at the pattern. Patterns become very important in elementary school. When we had two distinct points, we had 2 distinct rays. We had 3 distinct collinear points. We had 1, 2, 3, 4 distinct rays. When we had 4 collinear points, we had 6 distinct rays. So the question is, what if you have n collinear points? How many distinct rays would be created? Let's see if we can find the pattern. So if we had 2 points, we had 2 rays. 3 points, 4 rays. 4 points, 6 rays. It looks to me like if you have n points, you're going to have, so let's see, 2 is equal to 2 times 1. 4 is equal to 2 times 2. 6 is equal to 2 times 3. Okay, so what we have is some factor of 2. 2 points, 2 times 1. 3 points, 2 times 2. 4 points, 2 times 3. Looks to me that if we have n points, the pattern, the number of distinct rays that we created, would be 2 times 1 minus the number of points, or n minus 1.